Good morning. In this session, I am going to discuss about photodetector used in optical fiber communication. Moving into this photodetector, we'll have a basic idea about the fiber optic receiver. What is the major function of this fiber optical receiver means? It is used to convert the incident optical power into its corresponding variation in the electrical current. So it is mainly for converting optical to electrical. Designing this optical receiver is more complicated than designing a transmitter. But even though this detector in the receiver will play a vital role in optical communication, the receiver has to detect the weak, distorted signal and then it should make a decision on it. We are having two types of photodetector used in this fiber optical receiver side. One is PIN, pin photodetector, another one is avalanche photodetector. And here the major requirements of photodetectors are listed. First is listed here is it must shows high responsivity at the operating wavelengths, at any operating wavelength, but it shows good responsivity. And in communication, fidelity must be good. Here also we need the same requirement. And next, for an incident optical signal, it should give a larger electrical response. And for a suitable wavelength, it should produce the response in a very short time. And we expect a minimum noise, size must be small, cost must be less, and some more requirements are listed. And our next topic here is detector, photodetector, in specifically pin photodetector. Here in this screenshot, I have shown the circuit, pin photodetector circuit with reverse biasing condition. Regarding the structure of this pin photodetector, it contains P region, N region, and both are separated by means of a very lightly N-doped intrinsic region, which is represented as I. And this photodetector working condition has two phases. First phase is normal operation phase, second phase is photon operation. What is this normal operation means? When the photodiode is reversed biased, the intrinsic region of the diode is fully depleted by means of its carrier. This is normal condition, normal biasing condition. And second one, after a photon of energy, h mu is incident on the depletion region. What happened? This is the second phase. So because of the second phase, we have its corresponding electrical signal. So what happened? We're just going to consider a photon of energy h mu, which is incident on the depletion region. There, the photon gives up its energy and excites the electron from the valence band to the conduction band. This process leaves an empty hole in the valence band, and this is called as photogeneration of an free electron hole pairs, which is also known as photocarriers. This is mainly due to the absorption of photons. The structure shown here, when the photon incident, the movement of electron from valence to conduction, and it produces the photocarrier. Okay, so photocarrier, how it got generated, this can be easily understood by means of the diagram shown here. The next is Photocurrent. What does this photocurrent means? The high electric field present in the depletion region causes the carrier to separate and be collected across the reverse bias junction. This will rise to a current flow in an external circuit. This current flow is known as the photocurrent. The next is we're going to learn is diffusion length. The diffusion length determines from the average movement of the charge carriers before recombination. Then carrier lifetime. Carrier lifetime defines a time taken by the electron or hole to recombine. Here, the charge carriers moves a distance before recombination is represented as Ln or Lp for electrons and holes respectively. This distance is called as diffusion length. We can relate the carrier lifetime and diffusion length by the given equation where dn and dp are the diffusion coefficients of electron and hole respectively, where tau n and tau p are the carrier lifetime of the holes and electron. Next, is we'll just learn about the characteristics of PIN diode. We had two important characteristics. One is quantum efficiency, another one is response speed, or we can call it as responsivity. The quantum efficiency is the ratio between the number of electron hole pair got generated as per the incident photon of energy h mu. So the quantum efficiency can be written as number of electron hole pair to the number of photons. Mathematically, we can write the quantum efficiency is eta equal to I suffix p by q divided by p suffix o by h mu. Ip is the photocurrent and q is the charge of electron, po is the optical power and h mu is the photon energy. And the last one is responsivity. What is response? For the something is given as an input, the system has to produce the response. So here to our optical receiver, to the detector which contains the detector, if you are given optical power as an input, it must produce the output as current. So we can define the responsivity here as it is the ratio between the primary current to the incident optical power. And mathematically it is represented as capital R equal to I suffix p by P naught, PO. So from this video we could able to understand the working operation of PIN diode and its two characteristics.